We're going to talk about the adrenal gland. The adrenal gland is incredibly important to our body. It's a very small gland that sits on top of either kidney that you probably don't think about every day, but we're going to talk about it and help give you a better understanding of what it is, what it does, and why it really matters. The adrenal gland is this triangular shaped gland sitting on top of either kidney, and it's made up of two different elements. We have our adrenal medulla that's in the center, this kind of horseshoe shaped piece in the center. And then we have the adrenal cortex, which is the outer portion that surrounds the adrenal medulla. The adrenal medulla, again, is the inner layer. It's responsible for excreting catecholamines, things like norepinephrine and epinephrine, and we'll talk about that in just a second. The adrenal cortex, or the outer layer, is responsible for excreting mineralocorticoids, glucocorticoids, and androgens. So the adrenal medulla, again, the adrenal medulla is this center layer, this horseshoe-shaped center layer of the adrenal gland. It's made up of these specialized sympathetic neurons called chromaffin cells. They don't have any axons, they don't have any dendrites, and what they do is when it's stimulated, epinephrine and norepinephrine are released. Now, you've probably heard of epinephrine or norepinephrine before. Norepinephrine is a neurotransmitter. Epinephrine, aka adrenaline, plays a role in this fight or flight response. So it's going to do things like increase our heart rate, increase our blood pressure. It's going to shift circulation to the skeletal muscle, increase ventilation in the lungs, and it's going to inhibit some of these quote-unquote less important functions, things like digestion and excretion. The whole purpose of this is to prepare our body for this flight or fight response, to get us ready to move, stop all these things that don't need to be going on for us to fight or for us to run, and those things would be digestion and excretion. Imagine you're being chased by a lion. The last thing you want is to be going through the digestive process or the excretion process. You need your heart to be going faster, you need your blood pressure, you need your lungs going. And that's what is really important in this fight or flight response, and epinephrine plays a huge role in that. It also creates this hyperglycemic effect through gluconeogenesis and glycogenolysis, both of those kind of leading to increasing glucose in our blood. Now, why would we want that? It's going to inhibit insulin, increase glucose in our blood, all for the purpose of increasing the amount of glucose that can get to our brain. We want our brain to be able to function. It's a massive consumer of glucose, and so we're really trying to create more glucose, get it all up into the brain. All right. Now, how is this associated with the adrenal cortex? So stress stimulates these medullary cells to secrete all these catecholamines, epinephrine, norepinephrine, and this stimulates the cortex, the adrenal cortex, to release corticosterone. So with that, let's get into what the adrenal cortex does. Again, the adrenal cortex is this outer layer of the adrenal gland. Its main purpose is to excrete or release steroid hormones, corticosteroids and corticoids. Now, we have a couple different kinds of these. We have mineralocorticoids, glucocorticoids, and androgens. Mineralocorticoids act on the kidneys to control electrolyte balance. So aldosterone, what it does is it leads to sodium retention. Now, water follows sodium, and so we're retaining sodium, we're retaining H2O, we're retaining water. At the same time, this leads to potassium excretion. Retain sodium, water follows sodium, potassium leaves. All right, so that's kind of the big role of aldosterone with electrolyte balance. Then we also have our glucocorticoids. We have cortisol and hydrocortisone. The main role of these is fat and protein breakdown. It also plays a role in gluconeogenesis, which is the creation of glucose. And it has a huge anti-inflammatory effect. Now, what you're going to see with this is long-term secretion of glucocorticoids, of cortisol and hydrocortisone, is going to lead to a suppression of our immune system. Now, if we have this long-term suppression of our immune system, it can lead to something called Cushing's syndrome. Now, we have a whole lesson on that. I invite you to go watch that. Now, the lack of secretion over long term can lead to fluid and electrolyte imbalances, and it can also lead to Addison's disease. Again, we have a whole lesson on that, and I invite you to go watch that. Now, we also have these sex steroids called androgens. They play a role in reproductive anatomy. For males, it plays a role in DHEA, which is naturally weak, but it's converted to testosterone in other tissues. Now, the testes are the main source of testosterone and make most of the testosterone in the male body. For females, the adrenal androgens comprise about 50% of all the female needs for androgen. For both male and females, it stimulates the development of secondary sex characteristics like pubic and axillary hair, and it plays a role in sustained libido. So let's review some of the key points really quick. The adrenal gland sits on top of the kidneys. It's this triangular shaped gland with two pieces. You have your adrenal medulla in the middle, and you have your adrenal cortex as the outer layer. The adrenal medulla plays a role in catecholamine release, epinephrine, norepinephrine, that plays a role in fight or flight. And then we also have our adrenal cortex, which plays a role in mineralocorticoids, glucocorticoids, and androgen release. We talked about how those play a role in the body. A big thing to keep in mind here is that the adrenal gland is a main source of our flight or fight response. It's the result of this catecholamine release, again, this norepinephrine and epinephrine release, that creates this fight or flight response. This is an incredibly important gland. I hope this helps make it a little bit more clear for you guys and kind of get those key points. Now, like we always say here at NRSNG, go out and be your best self today. Happy nursing.